Hello and welcome to the 15th edition of International Observe the Moon Night. This is a day each year that we invite everyone on Earth to observe the moon, learn about the moon, and celebrate the moon in our arts and culture. Hi, I'm James Tralie. I'm a producer at NASA Goddard.
Hi, I'm Andrea Jones, and I am the Public Engagement Lead of the Solar System Exploration Division here at NASA Goddard, and I'm also the Director of International Observe the Moon Night. So we are so excited that you are observing the moon right now. With about 1 million people around the world on all 7 continents, people are observing with you. We're so glad that you're here. And wherever you're joining us from, we'd love for you to show us where you are and how you are observing the moon. So you can share that with us and with people around the world using the hashtag Observe the Moon on your favorite social media platform. And you can share us photos with us through the Flickr group as well, linked through our website, moon.nasa.gov/observe. And there we have lots more program information and resources as well.
Yeah, so International Observe the Moon Night is an annual event that occurs usually in September or October when the moon is around the first quarter. This is a great phase for evening observing with dramatic shadows along the terminator. And here's how some of our friends around the world are observing the moon.
Todos los años, a finales de octubre, hay una noche especial en España. Es una noche en la que decenas de asociaciones astronómicas sacan sus telescopios a la calle. Estamos hablando de la Noche de la Luna, cuando juntos todos comparten su pasión por el cielo.
Nazywam się Kinga Gruszecka i zapraszam do wspólnej obserwacji Księżyca.
Nosotras somos como la luna. Cada fase es un cambio para llegar a nuestra plenitud. ¡Viva la noche de observación lunar!
Hi, I'm Matt here at the South Pole Telescope, celebrating the moon.
みんなで月を見よう. I'm focusing on the moon because humans will be expanding the area of activity in the near future.
Hello everyone, we are the Luminous choir from South Africa.
And we are so excited to be celebrating the International Observe the Moon Night with NASA!
Hi, I'm NASA astronaut Tracy Dyson, orbiting 260 miles above the Earth aboard the International Space Station. Tonight is time to come together to appreciate and observe our shared moon. We are blessed on the ISS to be able to observe the moon from space, being situated over the Earth's atmosphere. It's quite a sight to behold. The effect of the moon is most dramatic for us over large bodies of water. When the moon is full, it illuminates the whole surface of the Earth, and the ocean glistens with a beautiful soft glow. Contrast that with a new moon, and the oceans are as black as a starless universe. It's almost as if the Earth disappears. It's crazy. Wherever the moon is in its phase, when spotted, you can hear someone say from the cupola, "Come look at this moon." So my crewmates and I are excited to contribute to work that is stepping stone toward NASA's return to the moon through the Artemis program. Stay curious and keep looking up.
Yeah, so you just saw how folks around the world are observing the moon. But Andrea, do you have any tips for people to observe the moon? First, with a telescope, if they have one.
Sure. So if you're fortunate enough to have access to a telescope, there are some wonderful features to look for. We have moon maps that have lots of features identified, but something you might want to try is looking along the terminator, the line between day and night on the moon. It's the dawn and dusk line, just like here on Earth, and that's where the shadows are the longest, and so you can really see that rugged lunar terrain pop out.
It's really special to be able to do that. Definitely encourage you if you have a telescope. But if you don't have a telescope, you can still participate with the naked eye. What are some things you can look for if you're just looking at the moon?
Absolutely. So if you're looking up and you see those dark areas and those light areas, those are the 2 major types of rocks that we find on the moon. The highlands, the lunar highlands, the ancient rock, they're kind of bright. And the mare, these floods of basalt, are darker. So those are 2 things you'll definitely see. You might see some crater rays. Tycho crater is visible, and you can see some rays emanating from this little crater that's fairly fresh, and we know it's fairly fresh because of those bright rays. If you're not able to go outside to observe, you also can do different things. So right now you're watching this broadcast, of course. We also have telescope feeds from around the world on our website, on our live streams page, and you can really be creative. This is a moment that we're excited to have traditional observing, but there's also the opportunity to feel the moon with 3D prints of the lunar surface. You can taste the moon a little bit. You could make, moon phases out of chocolate sandwich cookies and try that out. You can listen to the moon. There's lots of moon songs, there's actually some lunar data that's sonified that you can listen to lunar data, or you can, listen to your favorite moon songs or moon movies or moon stories. This is a time to celebrate the moon in arts and culture, and we really encourage people to be creative with how they're observing the moon today.
So to learn more about how to observe our moon, we're joined by NASA data visualizer, Ernie Wright. How's it going, Ernie? Thanks so much for joining us.
It's going great. I'm very happy to be here.
Always good to bring you in for nights like these when we're looking at our nearest celestial neighbor, the moon. What gets you excited about looking at our moon?
Well, International Observe the Moon Night is this time for everybody to observe together, but I always think it's a good time to go out and look at the moon. I enjoy watching the phases change. It's like having a calendar in the sky. And I also enjoy, because I have telescopes and I'm an amateur astronomer, I enjoy watching the terrain change as the shadows play across it.
So this event always occurs when we have a near first quarter moon. It's a little bit of a bigger phase this year. So what are you going to be looking for tonight?
Yeah, so it's a waxing gibbous phase, which allows us to see some things in the western half of the moon that we normally don't see during this event. I'll be looking for Aristarchus Plateau, which is right on the terminator, that day-night line, because that throws a lot of the terrain right there into relief. Aristarchus Plateau is this sort of diamond-shaped volcanic feature that's lifted up above the rest of the surface, and you can really tell that when the shadows are long the way they are. You'll also be able to see more of Copernicus crater, which is in the middle of a mare, but it's very bright and it has all these rays, all these ejector rays. Just imagine the explosion that happened when that crater was formed to throw stuff out hundreds of kilometers in every direction.
So Ernie, today is a day that a lot of people will be maybe taking time to observe the moon. Who knows, perhaps for the first time, like really paying attention to the moon at all. And a lot of people are going to be looking through a telescope for the first time. We know that a lot of people do that today. So if you haven't been paying attention to this amazing, beautiful world near us, what are some things that we should look for, just out in our backyards? And then can you talk a little bit about what that experience might be like to look through a telescope?
Through a telescope. I think it will surprise a lot of people how amazing that view is. When my kids were in second grade, I would take a telescope up to the elementary school during the day because the third quarter moon is visible in the western sky. And all the kids would sort of line up and look through. It's a little difficult to sort of aim your eye right down the barrel of the eyepiece, so you may not see something right away, but I could always tell when the kids actually got lined up and saw it because they'd all go, they would make faces, they would gasp, they would get excited, they would start jumping up and down. So I think even the grown-ups will jump up and down on the inside when they look through a telescope for the first time at the moon and see how complicated and uniquely beautiful that surface is.
And we want to hear about your first experience. If this is your first time looking through a telescope, be sure to share that experience with us using that hashtag #ObserveTheMoon. And while we observe our nearest celestial neighbor here from Earth, we actually have one mission up in space getting an even closer look at the moon.
Since its launch in 2009, NASA's Lunar Reconnaissance Orbiter has been gathering incredible amounts of data about the moon. This information has led to many scientific discoveries, shedding light on the moon's history, composition, and potential for future exploration. One of the most heavily used instruments on LRO is its high-resolution camera system, which is able to capture incredibly detailed images of the lunar surface. By analyzing these images, scientists have been able to gain new insights into the moon's geology and its evolution. For example, LRO has provided new data on how the lunar surface changes as a result of the formation of impact craters. During its years orbiting the moon, LRO's camera has captured the immediate results of meteorite impacts on the surface, such as scattered debris and ejecta patterns on the surface. And since the moon lacks an atmosphere, these newly formed craters remain essentially untouched over many years, allowing LRO to continuously measure and collect data on them. This means scientists can analyze a crater formed a year ago and use it to learn about craters that formed millions or billions of years in the past, giving us clues about the moon's geologic history. We can't replicate this type of study on Mars or on Earth, since atmospheric conditions like wind are rapidly changing the surface. The moon is therefore a unique environment for learning about our solar system. Another major focus of LRO's mission has been the moon's south pole. This region is of particular interest to scientists because of the detection of water, which will be a vital resource for future missions to the moon. The data LRO has collected allows scientists to create detailed maps of the South Pole, leading to the discovery of large regions that appear to contain significant amounts of this water. These discoveries are important because they could help make future missions to the moon more sustainable. Instead of having to bring all their own water with them, astronauts could potentially extract water from the lunar soil and use it for drinking, cooking, and even rocket fuel. The Lunar Reconnaissance Orbiter spacecraft is also equipped with a suite of scientific instruments that aid in exploration, including a laser altimeter called LOLA that is able to measure the precise elevation of the lunar surface. Using LOLA, scientists have been able to create the most accurate map of the moon's topography to date, as well as improved lunar gravity models, both of which will help future exploration efforts. Finally, data from LRO has helped us better understand the composition of the lunar surface, shedding new light on the moon's history. The data has shown that a wider range of compositions of volcanic rocks exist on the lunar surface than previously thought. We have found compositions of rocks that are not part of the Apollo sample collection, and evidence for volcanic activity that may have occurred only 50 million years ago. That's 950 million years after scientists had previously thought it ended. This information helps us piece together a geologic history of the moon from just after its formation to the present day, information that will aid in understanding future samples collected by Artemis astronauts. Thanks to the incredible data gathered by the Lunar Reconnaissance Orbiter, NASA and the scientific community are making incredible strides in our understanding of the moon. With every new discovery, we are one step closer to unlocking the secrets of our closest celestial neighbor.
So you just saw some of the ways in which NASA observes the moon, and so we're back here with Ernie to learn more about how data visualizers like himself use these data to create some incredible visualizations of the moon. So Ernie, so you get all this data back from LRO. I'm always curious to know what your approach is to kind of distill that down into the beautiful imagery that we see.
I feel so fortunate to be working with LRO data because this is the first time that we have complete global maps of the moon, including the shape of the surface, and that's what gives you those beautiful shadows. And that's kind of, the moon is this very stark landscape, and without the shadows, you don't have a whole lot to show. So I use all of these maps of the surface shape and the surface color, and I put the sun in the right place, and sometimes I put the camera where the Earth is, so far away with a big telephoto lens, like I'm looking through a telescope. And really, all I have to do is point at the moon, and there's so many beautiful things to see there.
Yeah, the resolution is crazy. Can you give us kind of a sense of scale, like as per pixel resolution that you're able to...
So the cameras on LRO, there's a wide-angle camera that's 100 meters per pixel, and there's a narrow-angle camera that can get down to half a meter or even better. This is what has allowed us to take pictures of the landing sites of the Apollo astronauts. The descent stage of those landers is still there. We can't see the flags, but we can see the shadows that the flags cast. And we can see their footprints. We can see the tracks that they left, and we can see the rover tracks, and we know exactly where they went. We can see the rover. Apollo 15, 16, and 17 had a dune buggy that allowed them to travel for miles on the surface. And the other really important component for me is the laser altimeter. This is a laser that fires shots at the surface 28 times a second, and has a clock in it that can time how long it takes that laser light to leave the spacecraft, hit the surface, and come back again. And we're talking about fractions of nanoseconds. But that tells you exactly the height of the surface that they're firing at. They've shot that laser over 10 billion times. And so we have maps of the shape of the terrain based on that are 60 meters per pixel near the equator and 5 meters per pixel at the poles. The advantage of a polar orbiter like LRO is that it goes over the pole lots and lots of times, and all of those tracks are squished together, so you get really high resolution there. And that's fortunate for us because we kind of want to land there at the South Pole. Yeah. And so we know the shape of that terrain better than any of the landing sites in Apollo, and it really helps with the planning.
Your mention of the South Pole, I mean, we are doing a lot to get ready to continue exploring the moon. We have been with LRO for a long time now. It's amazing how fantastic and long-lived the spacecraft is going, the little spacecraft that could.
Yes.
But we're also learning a lot with your visualizations. They're stunning. They're beautiful. This is like my favorite meeting, is learning what Ernie has created with this data that's a little bit hard to approach in raw format. But we're also benefiting as a science community from your visualizations. So can you talk a little bit about the types of mysteries you're helping to solve, the types of puzzles, the types of challenges that your work is helping us overcome as we're exploring the moon and learning about it?
I always think of myself as an artist with no talent. And so what I try to do is use the computer as my sort of talent aid. And my approach has always been the more realistic I can be in my rendering, the closer I can get to the beauty of nature. This is something that I don't have to work at. It just comes out of doing things that show what it really looks like. And so for deciding where to land when we go back, it's really important to get that illumination right. At the South Pole, the illumination is just bizarre. The sun is never more than 1.5 degrees above the surface, and so you get these gigantic long shadows that are cast from mountains that are over 100 kilometers away. If your spacecraft is powered with solar panels, you kind of need to know if you're going to be in shadow or not. So I hope that when I visualize the illumination at the South Pole, it's helping to choose the landing site and plan how we do our EVAs when the astronauts step out and explore the surface. Do they have to walk through shadow? Can we use Earthshine to sort of help in those situations? What is the big difference between summer and winter? You wouldn't think that the moon would have seasons as extreme as the Earth's, but if you're at the South Pole, it makes all the difference, whether the sun is 1.5 degrees above the horizon or 1.5 degrees below. So that's what I'm trying to do now, is help people understand what that lighting situation is.
Yeah, and also I guess this work we were talking about is preparing the next generation of astronauts for Artemis. What does that mean to you that your work, your data is being used in this situation?
It's so cool. I have been sent pictures of astronauts in training who are looking at my visualizations and identifying features on the surface and understanding how changes in lighting make things more difficult. This is actually something that during International Observe the Moon Night you can see for yourself. On the eastern side of the moon, you'll see that the craters kind of disappear. What you see is the coloration, but because there aren't very many shadows there, you can't tell what the shapes are. And so I think it's helpful for the astronauts to see what everything looks like under different lighting conditions and how something that on a map you might say, oh, I know exactly where that is, but if the illumination is different, you might not see it that way at all.
And you have such an incredible knowledge of all the features of the moon. I always wonder, what is a feature on it that kind of draws you back in every single time you see it when you're looking through this data?
Well, I've been staring at the moon for 15 years now, and you kind of have to. So I like unusual things like Reiner Gamma, which is this swirly feature. It's not a crater. It's not a shape on the surface. It's a coloration that we think is caused by local magnetic fields that sort of are redistributing dust particles. It's a little bit like the magnetic face that you can kind of draw mustaches with. That's happening on the surface of the moon, and we call those swirls. But Reiner Gamma is the most obvious one, and you can see that through an amateur telescope. in an amateur telescope, it looks like a little figure 8 that's drawn on the face of the moon.
Yeah, it's amazing you could see these in real time. I think of like the Shoemaker-Levy 9 impact on Jupiter. Is there anything that you've been able to capture in real time with LRO here at the moon?
Yeah, LRO is detecting a lot of meteor impacts. And I mean, we say meteor, that's kind of an Earth thing. It's the bright flash in the atmosphere, but there are also these particles that are hitting the moon and small boulders. And we have seen flashes on the Earth that indicate that an impact has occurred, and LRO can fly over that later and see a new crater. And because it's been there for 15 years, it has older pictures of that area. And so we can kind of do that two-frame GIF of craters there, craters not there. And you can see crater formation processes that are happening right now. In fact, I was surprised to learn that based on this, they call it the gardening rate. This is how fast the surface changes. That rate is probably 100 times faster than we thought it was. This has implications for the astronauts' footprints. We thought they would last 1 million years. They may only last 10,000 because there's still so much activity on the surface, right?
It is really incredible. LRO has helped us reshape our understanding of our nearest neighbor in space. And so much of your work has helped us understand what is going on. And there is a 15-year collection of Ernie's work helping us look at some of the neatest highlights, the greatest science results, and all kinds of beautiful areas that we can observe on the moon. So.
And it's been such a privilege to work on that data and actually see that happen and see scientists see things that they didn't see before. It's this time capsule of the formation and evolution of the entire solar system. So everything you learn about the moon tells you something about where we came from, where the Earth came from, where the rest of the solar system came from. And to see that understanding grow in real time based on LRO's data is really amazing.
And you've combined all of this data into, I think, in my opinion, and probably everyone's opinion at NASA's favorite video of yours, which is this one set to Clair de Lune by Debussy. Moonlight. It's a beautiful visualization, and we'll watch that now, and I encourage you all to just enjoy and take this one in.
These data are not only visually stunning, but scientifically interesting and important as well. They're helping us better understand the lunar environment and prepare for future exploration.
And so while we study the moon using missions like the Lunar Reconnaissance Orbiter, we also continue to make new discoveries from the samples that astronauts brought back from the Apollo program. Here's how scientists at NASA's Johnson Space Center are analyzing this precious collection of lunar material.
This is the only place in the world that you go work with moon rocks on the scale that we work with them and handle them every day. It's so exciting that the astronauts brought back the samples and they're here at Johnson Space Center. My name is Andrea Beatrice Mosey. I've been working here at NASA for 47 years.
My name is Juliana Gross. I am the Deputy Curator for the Apollo samples. My job rocks, obviously.
On a daily basis, I work with moon rocks. There were 6 missions that went to the moon from 1969 to 1972, and we brought back 842 pounds of rocks, pebbles, and soil.
We're studying moon rocks because we want to learn about our own history. We want to learn about how Earth formed, where life comes from, where's the water coming from. And all that information is lost on Earth, so we need to find that someplace else that hasn't changed so we can still find that original information. And that's on the moon. The moon doesn't have any wind and water and rain. The moon is geologically inactive, so nothing has changed. It has recorded everything since its formation. So it has recorded how the sun has changed over time. It recorded how much stuff got delivered to the moon, like hit the moon over time. We can look at the age of these rocks and then make assumptions of like what was delivered at what time. So the moon is like a time capsule or a time machine. We can go back in time and look at it.
The moon rocks are stored here at Johnson Space Center in our pristine sample vault and our return sample vault. We actually break the rocks, document the samples, find out exactly what the scientist or the researcher is looking for, and we allocate or send the samples to them to do their research. You cannot actually touch the samples with the bare hand. If in fact I touch the samples with my bare hands, then I'm adding the oil to the samples. So when the researchers actually do their analysis, they're not researching what was actually found on the moon. They're researching what we have here on Earth. We work in a clean room lab. We have microscopes that we keep covered with the bag when we go out, or you have data that you're working on in your data pack. Everything we do here is to protect the samples from earthly environment. You need to keep the room clean. When your parents tell you to go and clean up your room, just think about that. I want to work in the lab with the moon rocks. I better learn how to clean up this room.
All the Apollo samples are special, but they're not representative for the rest of the moon. And so that's one of the reasons why we're going back to the moon with the Artemis missions, and we're going to go to a South Polar region. The astronauts actually got geology training so that they could recognize different rock types. When we train the astronauts, we want them to be able to pick up rocks that are representative of that landing site, but we also want them to pick up rocks that are very diverse. So we really can get a better idea of what the geology is like in that region, not just the landing site, but the overall region. And that's why this is so fun, because the Artemis astronauts will learn from the Apollo astronauts, and they will learn from the Apollo samples to prepare them to go back to the moon and pick up new samples that are more representative.
I've been here for 47 years because I actually love what I do. The samples from Apollo, it sparked what we're doing now. So we continue to do that same research. We continue with exploration, and that is NASA's mission. If you're interested in becoming a processor of moon rocks, you should start studying now earth science and geology. It's a good thing to find a mentor. There are also teachers and counselors that will assist you. Don't be afraid to reach out to them. There's no dumb question. So you need to be able to open up, ask the questions. You need to be present, but present does not mean just being in the class. Presence means participating, asking the question, doing your homework, and doing all the things that you need to do to be successful.
No, I never thought that I could work for NASA. That was like, NASA was just like big, shiny, only like geniuses work there, right? I was like, nah. I'm not good enough for that. And here I am. Don't listen to anybody who tells you you can't do things or you're not smart enough or like, no, whatever. Don't listen to them because they're wrong. Because what that really means is that you haven't found the right people to teach you in the right way that is good for you. Don't give up. Stay curious. Ask questions. Follow your heart. Just keep trying and you will eventually get there.
What's so exciting now is that we are heading back to the moon with astronauts again in the very near future.
Yeah, it's very, very soon. In fact, actually, just recently in late 2022, NASA launched the uncrewed moon orbiting mission Artemis 1 that officially marked a new phase of lunar exploration. This mission was the first in a series of increasingly complex missions that will enable human exploration at the moon and future missions to Mars. It traveled 1.4 million miles over 25 days, 10 hours and 53 minutes to be precise, and ventured thousands of miles beyond the moon.
While engineers and technicians prepare for Artemis 2, the first crewed mission in the program, scientists on the ground are working to train our astronauts.
And we have one of those scientists actually in studio with us today. This is Kelsey Young from NASA Goddard. Thank you so much for joining us.
Thanks for having me.
Yeah, so you were involved in quite a bit of training recently, most recently in Iceland. Could you talk a bit about that for us?
Yeah, I'm so fortunate to get to train not only the astronauts, but engineers, flight controllers, operators who are supporting Artemis. But most recently, I was incredibly fortunate to take place in training our Artemis 2 crew, who are of course, the next crew to go to the moon. They'll be traveling around the far side and coming back. So we had the prime crew and the backup crew out in the highlands of Iceland training them for their mission. It's incredible.
That's a cool place to be.
I mean, just casually, I'm going to lead these things. This is incredible.
I feel so fortunate, and I think my favorite part of the job is all the amazing people I get to work with. It's incredible.
Yes, so what is some of the science that we're going to be doing during Artemis 2 specifically that we're going to get involved in?
So Artemis 2 is the next mission out of the gate. So we'll have astronauts going to the moon, going around the far side and coming back. They'll get some great views of the far side, which human eyes don't get to see a whole lot, not since Apollo has anyone seen the far side of the moon. So we're going to be asking the astronauts to take pictures, of course. We want that documented since we all can't see it back here on Earth. And we want them to describe what they're seeing. So they'll be recording their observations, they'll be taking pictures, they'll be annotating images and maps of the moon, and they'll all be doing that around targets of interest that us lunar scientists and geologists care about and are asking them to look at.
And so you're doing this training in classrooms and out in the field as well. So you were just out in the field with this astronaut crew, the Artemis 2 crew. Can you tell us a little bit what that was like?
It was amazing. Yes, we do train them in the classroom and the field so they don't get out of the classroom work, right, to learn geology and lunar science. So we did have them in the classroom first and taught them a little bit about the fundamentals of lunar science, lunar geography, and also Iceland geology so they'd be prepared for the rocks they would see in the field. And then we traveled to Iceland. So we flew into Reykjavik and traveled up into the highlands. We had them looking at complex field geologic problems to kind of get their geology brains working, teach them about how to think about science in the field, how to unravel geologic problems and questions, make good observations, and take good pictures so that when they're flying around the far side of the moon, they can do that for us.
So it's back to school for everyone, including the astronauts.
Absolutely. Yep.
And so what is really striking, I think, and what I didn't really expect is that this is not a new program. We've been doing this since Apollo, training astronauts in geology.
Yes, and actually all the way back to Apollo, they visited this exact site with the Apollo crews, and they said it was the most lunar-like of the sites they visited during training. So we have that feedback from them of having been to Iceland, then flown to the moon and made that comparison. But since Apollo, we have been training crews. So we, again, classroom training, can't get out of that, and field training as well. So before they fly to International Space Station, astronauts train in geology as well, and we're building a new program for Artemis. And so new classroom content, new field content. We have 5 field sites that we're flushing out to take Artemis crews to, Iceland being one of them. So it's a really exciting new landscape of training, and we have an incredibly amazing and diverse group of trainers to provide them that classroom and field training.
Artemis 2 is not actually going to land on the moon, and yet this is part of their training regime. And can you explain why that's still so important, even if you're not going to be walking on the moon, to understand what it looks like to be walking around in that type of environment?
Yeah, so for the same reason we train International Space Station astronauts in geology and, field science, earth science, is because they're taking pictures from orbit on the International Space Station. We want them to, while they're taking the pictures, understand what those features look like from the ground, so they know what's interesting, they know what scientists back on Earth are going to care about in those images, they understand the processes that are taking place. By the same token, we want our lunar astronauts to be able to understand the terrain that they're flying over and imaging and describing, and the best way to do that is to get their hands on the rocks. So we have them out in the field looking at those rocks, looking at those landscapes, describing them, saying geology words out loud, taking good pictures and understanding what makes a good picture. It's all really valuable training to, put scientist-trained brains in around the moon.
And obviously we can't simulate the moon exactly, the gravity conditions, all these other things, but I feel like you do a pretty good job, even down to like the lighting conditions and the equipment. It seems like everyone's gowned up almost in what they'd be wearing when they're at the South Pole. It's often at night that you do these activities too.
Yeah, so the jet activities that we do out in Arizona, we do try to simulate the really challenging illumination environment that we expect at the lunar South Pole. So we get not just our crew used to those conditions, but our flight control teams as well, the teams supporting from Earth that are going to have to provide that, safety, navigation, science support, all from Mission Control Houston. So the jet simulations really enable us to really get comfortable in that environment and test the hardware that the astronauts are going to need to use to, light their path.
I'm also curious about your role and how this training affects your preparations for Artemis 2. So you will be on a mic, able to talk with astronauts as they're going around the moon. I mean, this is just so exciting. And how is this? I mean, this is, of course, relationship building and trust building. Is there anything particular that you are still working on as you're preparing?
Yeah, so my role for Artemis 2, I'm the lunar science lead, and I will be one of our science officers in mission control during the mission. So while I won't be talking to the astronauts, I will be talking to the flight director and the Capcom who are communicating with the astronauts, speaking for lunar science and geology. I'm incredibly excited. This is a new flight controller position for Artemis, and we're kind of the first through the gate here. We're so excited to be able to integrate science in this operational way for Artemis and for lunar science. And this Iceland trip, you hit the nail on the head. It's so important for, building relationships, not only with the crew, but we had flight controllers out there, we had a flight director out there, we had the chief training officer for the astronauts, which she plays a critical role in their journey to the moon. And it was just a really wonderful environment to all learn together, not just about the science, but about team building, expeditionary skills, team skills, how to work in these, high fidelity and operational environments. And it really, really brought the team, it really gelled the team together to work through adverse conditions. It's cold, it's rainy, it's foggy, we're all tired. How are you going to function and still, conduct science operations in these environments? That was one of the biggest impacts of the trip.
Yeah, there's so much preparation that goes into this. Could you kind of walk through, I guess, the schedule for the next couple of years leading up to Artemis 2, Artemis 3, and beyond?
Artemis 2 will go around the far side of the moon, and Artemis 3 will land on the moon. We have a lot of work to do. The Artemis 2 crew has, of course, a lot of work. We will provide more science training to them, specifically about their mission objectives. And then, of course, after the Artemis 2 mission, we'll turn our eyes to the surface of the moon. We have a whole really integrated training regimen planned for the Artemis 3 crew that includes pure science, classroom training on lunar fundamentals, lunar geography, geology, field geology, and, of course, field training. But we also are integrated with other operations teams, specifically the EVA group, or, again, an acronym, the Extravehicular Activity Group. So we're really joint with them because a lot of the science that the crew will be conducting on the moon is joint with EVA, right? They'll be doing it in their spacesuits out on the surface of the moon. And so we really need to speak each other's languages. As a science flight controller, I need to understand, the operational environment they're in, the dangerous environment they're in, and what those constraints are. And by the same token, all of those other operators need to understand the science and why we're there, why we're asking them to pick up that 12th regolith sample and take that third drive tube. So it's about language and culture building.
And there's a lot of thought that goes into even just the design of simple tools like a hammer. I remember talking with our tools engineer before about just the simplicity of things that you think you could just pick up any hammer, but everything has to be very specialized to that exact mission.
Scientists are so high maintenance. We have so many requirements. Yes, we have to be able to get the right type of sample with minimizing contamination, right? Because you don't want the human to contaminate the sample. You don't want the samples to contaminate each other, because then when you get that back to the lab, you want to make sure you know what you're looking at. And again, it's about building this culture and common language. We want the tools engineers to understand why scientists are saying, hey, can you please build in these requirements when you think about these tools? And we do that through not just meetings in the office, but taking them into the field and teaching them about geology. So again, it's so much more than training the astronauts. It's really creating this culture, this shared language of lunar science and exploration as an exploration team.
So as a member of the Artemis team, what is something you really want people to know about, to be excited about, something that is coming up that people around the world should be aware of?
I think one thing that often people can find surprising in my experience is how much we have left to learn about the moon. It's, the perception that we went to 6 different locations on the equatorial near side with the Apollo missions and learned everything there is to know about the moon could not be further from the truth. We visited a very narrow part of the moon. The Artemis missions will go to the lunar South Pole. This is a completely different geologic and geographic environment than we visited with Apollo. And one of my favorite, most inspiring facts about what the crew will be doing during Artemis is we can learn about our own planet by visiting the moon, things that we can't learn on our own planet, things that plate tectonics, that oceans, that vegetation have obscured and long since erased in our geologic record are actually preserved on the surface of the moon. So by doing an EVA and picking up samples on an Artemis mission, we'll be learning things about the history of our own planet, which I just find incredibly inspiring.
Yeah,
Going to the moon to learn about the Earth.
Yes,
Love
exactly.
it.
Yeah.
I think astronaut Jessica Watkins described it in our interview before as if like a space traveler visited Earth, saw Kansas, and was like, all right, that's everything.
Check the box.
Yep, that's everything.
Yep.
There's so much more to discover. So I guess what are you most excited about discovering?
My geologic background when I was coming up through graduate school was impact cratering. So that's a geologic process that has just covered the moon. Every step an Artemis astronaut takes will be impacted by impact craters. That's a process that's near and dear to my heart. And specifically, there is an extremely large impact basin near the south pole of the moon, the South Pole Aitken Basin. And constraining the age of this basin will allow us to anchor chronology, the history of the entire solar system. So I am hungry for that SPA sample. Yeah.
Absolutely. So much ahead.
And in the meantime, I guess while we're waiting in the wings here, we can be observing the moon. So today is International Observe the Moon Night. Mm-hmm. What makes you so excited about observing the moon?
Observing the moon, the moon is something that every human being on Earth has a connection to, and I find that extremely inspiring. For me, astronauts are going there. I'm spending my professional life right now dedicated to enabling that pursuit of exploration, specifically of our nearest celestial neighbor. That is extremely inspiring to me. But closer to home, it's a connection point. It's something that everybody can look at and experience together, which is why I love International Observe the Moon Night so deeply. I have young children. It's inspiring to know that they will grow up learning about this feature that's so important to me, but also so important to people everywhere. And it's a day where we can all share this experience together.
Awesome. Well, thank you so much for taking the time. Best of luck with all the training going forward for Artemis 2, Artemis 3, and beyond. And enjoy observing the moon tonight.
Thanks for having me, and you too.
This past year has been a big year for eclipses. We had both an annular eclipse when the moon passes in front of the sun, but does not completely cover it, leaving a glowing ring, and a total solar eclipse in early April of this year.
It's the heliophysics big year, and I was actually lucky enough to see the annular eclipse in person in Kerrville, Texas, which was a pretty mind-blowing experience to see live as part of NASA's coverage of the event. And so here are some incredible highlights from that awesome day.
Once in a lifetime, for all of us to be experiencing this.
Right there. It's a lunar eclipse.
Oh yeah!
Now that the annular eclipse is here, the fun has just begun. So today is the official launch of NASA's heliophysics big year.
Folks, we are moments away from the start of today's annular eclipse.
Mission that's going out into deep space, but these rockets,
there
which
we
just
go.
launched actually here.
Perfect.
This is...
We'll have 3 launches during the eclipse, studying that upper atmosphere, the ionosphere, kind of see what are those impacts from the sun.
This is negative Doppler shift due to the eclipse passing overhead.
4, 3, 2, 1.
Gina, I thought I'd have goosebumps, but I'm like literally shaking. This is crazy.
I know.
It's about the community and being communal, and just the unity of hearing everybody cheer. the sun touches us all in so many different ways. And so the heliophysics big year is going to help us kind of discover all the ways the sun touches us scientifically, but in other ways as well.
We also witnessed a total solar eclipse across America on April 8th of this year, and I was there to track this eclipse with a huge crew of NASA team members stationed across the path of totality. Andrea, it was a mind-blowing experience to see that live, and it's one that actually is not going to happen again here in the United States for a very long time, unfortunately, not until the 2040s. So if you missed out on that, or if you found yourself off the path of totality, here's what it looked like.
Welcome to live coverage of the celestial event of the year, the total solar eclipse. Today, NASA and the Great Lakes Science Center is hosting this free outdoor event for the community to experience the total solar eclipse. We will follow the moon's shadow as it races across North America.
We're live from the Kerrville Eclipse Festival.
We are at the Indianapolis Motor Speedway.
Things are looking absolutely fabulous.
We are here at Niagara Falls.
Crowds are filing into the stadium.
The solar corona is going to look very cool today. It's going to look cooler than it did last time.
You guys ready for an eclipse? 4, 3,
here we go!
1.
Wow. Look at that. Fantastic.
Oh my God, it's gorgeous.
Oh my gosh.
I think we're very fortunate to be here at this special vantage point to see such a special event.
Oh my gosh, that is gorgeous.
So we hope you were able to participate in this year's eclipse. However, if you weren't, don't worry, NASA has plenty of amazing citizen science projects for you to get involved with, including...
Yeah, we have one right up on our website today called MoonDiff. So this is a program where you can help NASA identify new impact craters that have been forming on the moon over the past 15 years through Lunar Reconnaissance Orbiter data, and also just different changes to the lunar surface. What is happening? What should we be tracking? What can we learn about our dynamic moon?
And yeah, so if you weren't satisfied with just one day of International Observe the Moon Night and you want to get involved with us beyond just tonight, what are some ways that people can get in touch? I guess share things, share their photos from today and beyond.
Well, certainly there's lots of places to share. Today, we're tracking Observe the Moon on lots of social media platforms. So I hope you're sharing with us how you're observing the moon and finding out what people are doing around the world right now. And throughout the year, keep in touch with us on NASA Moon social media and also our website, science.nasa.gov/moon.
So there's plenty of ways for you to get involved with these citizen science projects, but we actually have a crew of 4 NASA astronauts preparing to make the trek to the moon to conduct new science experiments and observations with the upcoming Artemis 2 and Artemis 3 missions. So let's meet our crew.
I'm Christina Cook. I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis 2 mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign of missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together. When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
Before stage engine start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence
on the lunar surface.
We are ready.
We are going
to the moon.
For all humanity.
We are Artemis.
So I actually recently had the chance to visit Mehdi Benna from NASA Goddard in his lab to learn a bit more about his Lunar Environment Monitoring Station, or LEMS. Let's hear a bit more about that. I'm joined today by Mehdi Benna from NASA Goddard. Thanks so much for joining us.
Hey, nice having you.
Yeah, so first of all, tell us where we are. What is this lab?
So you are here in one of the labs in the Planetary Environment Laboratory at NASA's Goddard Space Flight Center, an environment where we specialize in mostly building mass spectrometers, but also other type of instruments.
And instruments like this one right here. So could you walk us through what this is exactly here?
So this is an engineering model, a Lunar Environment Monitoring Station, or LEMS. So LEMS has been recently selected to be one of the three instruments that will be carried by the Artemis 3 missions.
And you told me before that this is basically like a spacecraft that you can deploy by hand with the astronauts. Right. How are they going to actually deploy this on the surface?
Yeah, so this is, as you can see, this is about the size of a carry-on suitcase. And so what you don't see here, it will ultimately have handles. It will be part of the Starship that carries the astronauts, all the payloads that the astronauts needs to the moon. When the astronauts get to the surface, they will take it off its storage area and will carry it by handle to the surface of the moon, and will deploy it, will drop it on the surface and do all the actions that allows it to come alive, which we call deployments.
And what's great about this too is the science will continue long after astronauts have left the moon, right? How long will this last and continue to take data?
The Artemis mission on the surface will not last more than a few days, but we designed the LEMS to be autonomous and so it can continue operating well after Artemis 3 crew has left the surface.
And we hear about earthquakes all the time here on Earth. We have seismic networks around the globe, but now we're going to be able to detect moonquakes. So first of all, what is a moonquake and how are we going to be able to detect with LEMS?
That's right. So like on Earth, when ground motions are called earthquakes, ground motion on the moon is called moonquake, and the origin of the ground motion on the moon is slightly different from that of Earth. On Earth is dominated by tectonic movements. On the moon, there is other sources for those quakes, mostly tidal effects. Basically, as the moon and the Earth rotate around the sun, the moon gets squished like a little bit, and that creates a lot of stress in the surface. We can have thermal quakes due to a transition between day and night. As the moon rotates around itself, we can have impact quakes due to asteroids and micrometeoroids hitting the surface of the moon. And so we want to basically listen to all these noises because they tell us a lot about the structure of the crust of the moon, but also tell us a lot about the constituents deep inside the lunar interior.
That's fantastic. And I guess how will this data help Artemis astronauts or any future astronauts that go to the moon?
As you know, the goal of the Artemis program is not just to return to the moon, but as actually to build permanent settlement on the moon. And so as soon as you're going to start building habitats and large structure, you really want to assess the seismicity of the location you are building all these, making these investment in. And so putting LEMS for ahead of the big push to build these structures will be very useful because we will collect the seismic data that will show whether that site is suitable for long-term basically construction of habitats, and will be safe for the astronauts to basically to stay in the area for a long period of time.
It is International Observe the Moon Night. So you mentioned when we were first talking that you observe the moon every single day. What do you love about the moon? Why do you observe it? What brings you back every day to look at it?
Well, as everybody else, I look at the moon because it's beautiful. It's a beautiful celestial body. Is one of the only celestial bodies that we can actually look at and distinguish features. Planets are just dots with the naked eye, but the moon is there for everybody to look at and admire. And I don't think anybody that can look at the moon can look at it without being intrigued by what that surface is telling us and what secrets that environment holds. So I grew up with the same curiosities, and I still have the same curiosities today. And so every night there is a beautiful moon up in the sky. I naturally find my head looking up there and still wonder.
Best of luck with LEMS for Artemis 3 and beyond. And
for being here.
Back to you in the studio. So thank you so much for joining us for International Observe the Moon Night, and keep an eye out for next year's event, which will be
October 4th of 2025. So we have a few more days going on right now. This is September 14th is the official date, but people will keep observing for a little while. Over the next few days, you will be joining 1 million people around the world, all over right now, observing, learning about the moon, celebrating the moon together. So thank you for being a part of this. We hope that you visit our website, moon.nasa.gov/observe, to learn more and share how you are observing the moon right now. See what other people are doing around the world on your favorite social media platform using Observe the Moon as a hashtag. And also check out our Flickr gallery. We have a lot of really wonderful pictures coming in, showing people observing the moon around the world.
Yeah, and we hope to see you. Already mark your calendars for next year, October 4th, 2025, for the 16th edition of International Observe the Moon Night. But for now, have a wonderful night, and we hope you enjoy your experience observing the moon.